All right, 2.6, graphs of rational functions. Alright, so find the domain of the function, use limits to describe the behavior of f at the values of x not in its domain. So we start out with f of x equals -3 over x minus 1.
What number is that?
Oh, number 2. So what values can x not be for this to be like a function? Well, x can be 0.
It cannot be.
I shouldn't really say for it to be a function. What can it, like, for it to exist, what can it not be? What can we not have?
A negative. An irrational.
A -1.
Where does this not exist? Or where is it undefined? When the denominator is 0. So we set the denominator equal to 0 and solve. So x equals 1. So our domain is everything except for 1. So our domain is -infinity to 1, not including union 1 to infinity.
Oh, because it can't be 0 and then the x equals 1 is your 0 basically?
Mm-hmm. X equals 1 is what makes it 0
Oh, okay.
in the bottom. So that's what we can't have. So then the second part says, describe the behavior of f at the values of x not in its domain. So we're going to say what's happening as x gets close to this value on the left side and on the right side. So we're doing in behavior again, but it looks a little different. So the limit as x approaches 1, and we put a little negative sign up at the exponent, that means from the left of f of x. So from the left, if we're getting close to 1, that's like 0.9999, okay? So what happens as I have that? So you have a -3 over 0.9999 minus 1 would be what? Positive or negative?
Could be
Negative. So negative over negative is positive, so it's going to positive infinity. Because if you did, like on your calculator, -3 divided by -0.00001 or whatever it was, then it's going to give you a really, really big number. So these ones, instead of plugging in infinities or whatever, you're plugging in a number. And then you're saying, is it going to positive infinity or negative infinity? So that's from the left. We need to also do it from the right. The limit as x approaches 1 from the right, so we put a positive sign up there instead of f of x. So if you have 1.001, for example, minus 1, it's positive on the bottom, negative on top, so it's going to negative infinity. Let's look at another one of those. Number 4, f of x equals 2 over x squared minus 1. So I set the denominator equal to 0 and solve. So x squared minus 1 equals 0. X squared equals 1. So x equals plus or minus 1. So it's all values except for that. Okay, except for -1 and 1. So I've got to do negative infinity to -1, not including, union -1 to 1, not including either, union 1 to infinity. So that gets rid of -1 and 1, but gives you everything else.
Thanks. You're welcome.
And now, because no matter what I plug in, the x squared is going to make it positive, I'm only going to do it for one of them
Oh.
instead of doing it for both.
Oh yeah.
So the limit as x approaches, so I'm just going to use the positive one. Positive one from the left of f of x.
So it'll just make it positive.
Well, so this is where I would have your calculator handy to look at, because, so you're looking at 1 from the left, so you're looking at like 0.99999, okay? Square that value, then subtract 1, and it's actually negative on the bottom. So you have positive divided by a negative, so it's going to negative infinity.
Squared.
Yeah.
So why are we only doing one instead of doing?
Because -1 would give you the same thing because it's being squared. Like the
Oh,
value
it would
being
still
squared is
be
going to
that.
make it.
It is.
It would still be
So
If it was different numbers, like if it was, say, -2 and +1, I would need to do both of them.
Okay, but since it's just -1 and 1.
Yeah. So if you do that, so you did 0.999, however many you want, squared, and then do -1, because that takes care of that part. Okay, so that gives you a negative value. And then if you do 2 divided by that second answer, that gives you a really big small number, if that makes sense. Like, so that's why it's going to negative infinity. Okay, so you can always check it that way, especially until you get used to what's actually happening in them. So then if we did 1 from the right, that means it's a number bigger than 1.
that would be positive.
Oh.
So that one's going to be positive.
Oh. I
Now, don't just assume that they're always going to be one positive and one negative one, because
Yeah.
that's not 100% the case. Could be, but don't just be like, oh, well, the first one was negative, so I guess the second one's positive.
Don't do that. Don't be like that.
Let's see. Okay. The next one's describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function g of x is equal to 1 over x. I don't really care about that. I care about the next part, which says identify the horizontal and vertical asymptotes, so your clown poem and the other thing. And use limits to describe the corresponding behavior. Okay, so for vertical asymptotes, we use this. For horizontal asymptotes, we see what happens at infinity.
Oh,
I feel like I should write that
It probably should have been in the notes somewhere.
down. Maybe.
It definitely is in the notes somewhere.
Oh, is it where it says vertical asymptote?
It would-
Correct the real zeros. So that's not.
It's this stuff.
oh,
Yeah.
Okay,
Yeah.
yeah, I got that.
Yeah,
Yeah,
that's
I
what
know.
it is. That's what it means. So, but if you want to write it down, that's fine. But so I said it a little differently there than it's written in the notes. But all right, so number 8, we have f of x is equal to 3x minus 2 over x minus 1. So I need my vertical asymptote and horizontal asymptote. And remember, vertical asymptotes are x equals whatever, and horizontal asymptotes are y equals whatever it ends up being. Okay, so vertical asymptotes occur where? Or when?
yes.
You just said it.
It's the same thing about domain.
Oh. X
No, X.
equals 0. Wait.
When
When
Oh,
the denominator something equals
when
0.
it's equal to
When the
0.
denominator equals 0.
You
So
know,
where
I
does...
didn't know that's what you were asking.
So where... Well, I said where, and then I was like, I guess I should say when. So, what is the vertical
One.
asymptote for this
One.
then? 1. Okay. You don't need to, I mean, you're welcome to show the work for that, but you don't, there's not really work to be shown. If it's something more than just that, then I would show me something so that I know, but. All right, horizontal asymptote. What scenario do I have?
Is the same.
Boba.
So, bigger on bottom is, I'm just sure refresher, bigger on bottom is what?
Equals 0. 0. Right?
0, okay. If they are, that's Bobo, Bosco, both the same, it's the
Use the coefficient.
coefficient, and if it's bigger on top,
There's not.
no, there's not.
the
Okay,
y
so
equals 3.
these are the same, so we use the coefficient, so y equals 3.
Wait, so what if the bottom one had a coefficient too?
Then it would be like if it was 2x, it would be 3 over 2.
3 over 2.
Mm-hmm. And if it was like an x squared term on the top and like an x on the bottom, that's obviously bigger on top, so yeah.
Yeah.
We don't care about all the other stuff if that happens. All right, so we're going to do the limits for, there's going to be 2 for the vertical asymptote. The horizontal asymptote, they're supposed to be equal, so we just set it up once. But let's do vertical first. So the limit as x approaches 1 from the left of f of x so that's like 0.999. So what happens to the bottom?
It becomes negative.
Okay, the bottom is going to be negative, but the top is going to be what?
Positive.
Positive, so it is
Negative.
negative infinity. And again, you could actually plug in a number to that whole equation and see what happens if you were so inclined, or if you don't understand just seeing it. It takes a little bit, so that's why I say that. The limit as x approaches 1 from the right of f of x, so if you have 1.001, on the top it's,
On the top,
Positive.
it's positive.
in the bottom it's positive, so it's positive infinity.
So you can just plug the 1 point whatever into the both x's just to find out if you don't.
Yeah, just find a number that's close to it and do it. All right, so then the horizontal asymptote, so I'm going to show you this again so that when you see how I write it, it makes sense. So we take the limit as x goes to negative infinity.
Okay.
So it's going to a point. That point is going to be whatever your horizontal asymptote is. But I recommend you check it because in case you did something wrong, then you would know. Obviously, if there's not a horizontal asymptote, then this doesn't apply.
Okay.
In theory, then, when you do positive infinity, they're the same. Well, they have to be the same. So I'm going to write it like this. The limit as x approaches negative infinity is equal to the limit as x approaches infinity is or I'm going to say of f of x. It technically probably should write it in both places, but is equal to, should be equal to 3. So when it's getting really, really big, I don't care about anything that comes after the first terms. Okay? So if I plug in positive infinity, or I have negative infinity written first. Negative infinity times 3 over negative infinity. The negative infinities cancel each other top and bottom, so you're left with 3. If I plug in positive infinity, they cancel each other top and bottom. You're left with 3. So it's equal to 3. Josh looks confused.
Yeah, can you say that?
So if you plugged in negative infinity, 3 times negative infinity, negative 3 infinity, okay, over negative infinity, the negative infinities cancel each other, you're left with 3. Just like if you had 3 times 2 over 2, the 2's are both going to cancel top and bottom. It's the same thing that's happening. That's why this is true. But in general, this just is true.
Yeah.
I'm more so just saying it for the sake of you checking to make sure that you've done it right.
I see, I understand. It's like,
Number 10, f of x equals 4 minus 3x over x minus 5. So my vertical asymptote is where
5.
x equals 5. Horizontal asymptote,
Three.
3.
negative 3. So these are written in the wrong order. So you could rewrite it if you were so inclined as negative 3x plus 4 over x minus 5 so that you see it. So y equals negative 3. So the limit, as x approaches 5 from the left of f of x equals,
What'd you do?
just move the boxes to the floor. So 5 from the left is
4.9999.
3.999. Wait,
From the left.
5.
Oh, 4.9. Yeah. So it would be.
It'd be 4.
Yeah, we're trying to figure out.
So just think, even if you just called it 4, I mean, not on the top in terms of just multiplying. 3 times 4 is 12. So 4 minus 12 is, it's negative. So then on the bottom, it's also going to be negative. So infinity. The limit as x approaches 5 from the right of f of x.
It would be positive. Wait, that's fine.
Bottom is positive,
Yeah.
Negative.
but the top is negative because it's minus that. So negative infinity. Then your limit as x approaches negative infinity is equal to the limit
It is negative.
as x approaches infinity is equal to what? Negative 3.
Can I use the restroom?
Find the horizontal and vertical asymptotes. Use limits to describe the corresponding in behavior. So number 20, f of x equals 3x squared over x squared plus 1. So vertical asymptote.
Plus or minus 1. Wait.
It's not plus.
Never mind. Never mind. It's not. It's not.
Why?
Because it's not real.
Correct.
We're
None.
squaring a negative
Oh, what?
Because it's plus 1, so there's no way that when you set that equal to 0 and solve, there's no way you can
So
get
it's
a value that would make that 0, unless it's not real.
1. Because then x squared equals negative 1. Take the square root of it.
So it'd be plus or minus I, which we don't care about. It's not real. Horizontal asymptote, 3. So there's no vertical asymptote, so I don't need to check the limits. So I just need to check the horizontal one. So the limit, x approaches negative infinity, is equal to the limit as x approaches infinity is equal to 3. And I know that seems kind of redundant, but I promise when you get to calculus, you will be glad that you did it this many times. Yes.
For horizontal asymptote, do you want us to write y equals 3 or just?
Yes, I do.
I think I might have led you astray because that just said 3.
You did, but it's fine. But it's fine. I'll give it to you. I didn't stop you, so.
You led me astray too.
Yeah, me too.
Peyton just didn't correct you this time.
Yeah.
See, Peyton just lets us make mistakes.
Unless it's Josh.
Yeah, and I call him out.
All right. Number 23 through 30, I'm modifying it a little bit in that you're not graphing. I only want asymptotes and intercepts. Intercepts, you're just setting the opposite variable equal to 0 and solving. Just, I think you know that probably, but. Let's do 24. G of x, mixing it up, equals x plus 2 over x squared plus 2x minus 3. All right, so let's do vertical asymptotes first. So how am I going to find the vertical asymptote for this one? Or what do I need to do to the bottom?
That's a factor.
I'm going to factor it first. So x squared plus 2x minus 3 equals 0. So what does this factor into?
Negative.
You need factors of 3.
It's positive 3.
3
negative
and
1.
Positive 3, negative 1. So x plus 3, x minus 1. So that means x equals negative 3, x equals 1.
After there's 2 vertical.
Yes. But you don't have to do the limits this time, so.
Oh.
This would be one where you would need to do it twice if it asks you for that, but it doesn't, so. Horizontal asymptote.
Undefined.
Y equals 0. It's bigger on bottom. So y equals 0.
Bring it on top another time.
Then I need to do intercepts. So the x-intercept, we set y equal to 0 and solve for x. So what just happened? We would have x plus 2 over x squared plus 2x minus 3 equals 0. Now, the trick for x-intercepts is that you really only need to set the numerator equal to 0 because the denominator, when you multiply it across by 0, it's gone. To undo this, I multiply it. Multiplying it by 0, it's gone.
Oh.
So all I need to do is the top equal to 0.
Negative 2.
So x equals negative 2. So my x-intercept, though, is the point negative 2, 0. Then the y-intercept, I set x equal to 0 and solve. So anywhere there's an x, I put a 0. So 0 plus 2 over 0 plus 2 times 0 minus 3. Now, obviously, you do not have to write in all the zeros. I'm doing it just so if you look back now, you would understand what happened. But so what am I left with?
2 over negative 3.
So negative 2/3. So my y-intercept is the point 0 and negative 2 over 3. Any questions about any of this? We're good. Sweet. And your problems are 1, 7, 9.
You would, wouldn't you?
What is that supposed to do?
I just wanted to
11 through 14 is just looking at a graph. So it's looking at, they give you a picture of a calculator graph and it wants you to tell what's happening as x approaches 3 from the left. So you need to look at, like, if you're coming from the left side of the graph as it gets close to 3, what is the graph doing? That's all you're doing is just looking at the graph and reading it off instead of doing it by plugging in numbers to the function.
Okay.
That's not going to be on like a quiz or a test. I just want you to get used to looking at a calculator because when we get to calculus, we do a lot more of just looking at the calculator graph and seeing what's happening. 19 and 23. So I'm just giving you a like 1 or 2 out of each of the sections that we did in here. So if you feel like you need to do more, if you're struggling with limits or asymptotes or anything, then do that. But otherwise, that's it.